afternoon. How you guys doing today? Good. Excellent, excellent. Well, guys, as you do hear, my name is Nitro Joe. And there's a reason. There's a very good reason why it's Nitro Joe. Guys, you see, I'm not some regular old-fashioned Joe, okay? Because this is not some regular old-fashioned science. No, no. What I want to do is I want to make things bigger, better, faster, wilder, crazier!
Might be me.
What I really want to do is I want to take a lot of this regular stuff and start drawing the science out and having a lot of fun with it, okay? That's really important. Now, you guys have to understand, all of this, even though it might get a little crazy from time to time, all of this is real science. So, whenever you do science, any kind of science, you always have to follow the rules. Yeah, rules and directions. They're real simple. They're easy. And I only have 3 of them, okay? They're called my 3 golden rules of science, designed to make certain everything works out well. They go like this. Rule number 1, there should be no talking while I'm talking. Now, that is a pretty simple rule, don't you think? Yeah, I know it's not always easy to follow, but it is pretty simple. And it's practical in this case as well. See, the reason why it's practical, let me explain. Let me tell you what you see. Guys, we're on stuff there. If we're on stuff there, I need help, and you're going to do it. You'll know what to do. You're going to grab another thing. You grab another thing up here, start mixing stuff up together. Next thing you know, everything around you just happens to go boom!
What?
Yeah. You got me, right? You got it? All right, okay. You guys didn't get it. It's pretty simple, okay? It's pretty simple. Everything up here is marked and it's labeled, okay? And you guys might not know what it is. On top of that, I also use a couple volunteers. I need people to help me out. Not yet. I'll catch you when it's time. But here's the thing. When you volunteer, I want you to know what you're volunteering for. The best way to do that is to listen, and the best way to listen, no talking on time. Pretty simple and easy. This leads me to rule number 2. Notice the table. I have many things on the table, underneath, behind the table. All of this is my science stuff. And sometimes, not all the time, sometimes my science stuff can be a little bit dangerous. Okay? I mean, I have chemicals up here that look very safe and simple. It's labeled, but this is poisonous. I have other chemicals up here that are corrosive. Okay? Do all of you guys know what corrosive chemicals are?
Safe chemicals.
Unfortunately, no. A corrosive chemical has a nasty habit of being able to melt the skin right off your finger. Kind of gross. And on top of that, on top of everything else, I have even brought something here today that does have the ability to freeze your nose off.
Yes.
Oh yeah. Now I'm sure you guys want to have your noses frozen off today, do you?
I want to. I do.
Oh, hang on. Your mom sent you here with your nose in your face. You can't go back home with your nose in your hand. Okay. Oh, you have permission slip. That's even better. All right. Let me tell you, guys, real simple. Rule number 2, please don't touch any of my equipment unless I ask you to. Okay? Pretty simple. And finally, most importantly, I have rule number 3. Rule number 3 is why I do what I do. Rule number 3 is what all of this science stuff is about. Rule number 3 requires. It means that each and every one of us must have fun. Pretty simple and easy, right?
Yeah.
All right, so we're going to have some fun. Now, here's the thing. I do science. I do not do magic tricks very often. On occasion, I will do a magic trick to show you guys the difference between science and magic. So, what I'll do right here is I'll grab some cards, and I have these big, oversized cards. Now, I'm going to get my cards all nice and shuffled first. Make sure we get a good shuffle. Then, I need someone to draw a card for me. Alright, now, whoa, hang on. Let me warn you. The person that draws this card for me must not be afraid of getting set on fire if I make a mistake. So, who's my knowledge?
I have permission slip for that.
Oh my gosh, you have permission slip for that one too. Okay. Let's see, who looks brave? Who looks courageous?
I'm the fire.
No chicken feathers. Not here.
She's scared. I don't even know you. Permission slip. She knows it.
Allison, this is fairly simple and straightforward. What I want you to do is I want you to take some of these cards, lift them up, turn them over, and put them back down face up. Okay? Just lift it up, turn it over, put it down face up. Yeah. Now do me a favor, take even more cards, go even deeper, lift up more cards. Do the same thing, flip those over, put them down face up just like so. That's right. It's just a cut shuffle. It's pretty simple. Okay. Now, Allison, I can see these cards on top, right? I don't want these cards. I know what these cards are. What I want to do is go to the back. When I get to the back of the first card that I don't know, Allison, I want you to take that card, hold it up high, show everybody else. Don't show me. Don't tell me. So I can't see. Put it flat against your stomach so I can't see. Flip. All right. Magic. Magic is all about someone trying to trick you. I mean, that's what I call magic tricks. Okay?
Yeah, it's a trick.
That's right. Magic is about someone trying to fool you. The key word in magic, what magic is all about, magic is about deception. Everybody say deception. That's magic. It's deception. However, with science you get to learn more. With science, you get to grow more. With science, you get to make and have bigger and better things. So, here's what I'm going to do. Allison, do me a favor. Put that card in my hand face down so I don't see it. Face down. Right here. Good. And then, I am going to take my card here, and I'm going to start to tear on it a little bit. Start to rip it. Now, I'm tearing it and ripping it for a reason. I want to improve the airflow. Okay? Now, the reason I say I want to improve the airflow is because I'm not just going to damage this card by tearing it. I want to improve the airflow so that I can take my card, put it inside my tongs, then I can add some fire to this card. Ah, yes. Woo. Let's get it all nice and lit here. I want a nice roasted card. There we go. Good. See? As this card burns, it starts to give off light, just like a candle. Okay? It starts to give off heat. It starts to make smoke. Then it starts to make all that black stuff called ashes. Okay? You guys see it? Whoa! We're good. You're good, right?
What about your hair?
Yeah. Might be a little smoldering there. We want to be easy and careful. Easy and careful. Okay, so we're just going to check. We're going to make certain, hopefully, won't happen. Oh!
Burnt bacon. It's scary.
You know what? I got a better idea. In order to make certain, let's have Allison open this up for us, nice and easy. Go ahead, you got this.
It's not going to be fine.
All right, it should be fine. Whoa! Reach in there. Pull it out. Show everybody. Pretty easy and simple trick, right? That's how it is. Hey, Allison handled that well. Give her a big round of applause for helping out. Look at the cards. They're shiny, glossy. Different shapes, different colors. But these cards are just made out of paper. That's right. Paper is what makes this trick work. Let's take a regular piece of paper. I got a regular scrap piece of paper. Now, let me ask you a question. If I take this piece of paper and I tear a piece off, is it still paper?
Yeah.
Of course it is. I mean, it's still paper. All I do is tore a piece off. What if I take this same piece of paper right here, hold it really tight, make a big mean face, and I just go, "Grrr!" Is it still paper?
Yeah.
You sure? Yes, it's still paper. All I do is I made some more noise, I yanked on it pretty hard, but it's still paper. So if I rip it, tear it, crumple it up, even toss it in the air, it's still paper. I didn't change what it is, I just changed the way it looked. In science, we call this a physical change. Okay? It's pretty easy. Now, let's take the same piece of paper right here, and then let's add some fire to it. Is it still paper then?
Yes. No.
It's more than ashes. Remember, we get 4 different things. What do we get? We get light, heat, smoke, and
Fire.
4 different things out of one piece of
You
paper.
get fire also, don't you?
So, here's what's going to happen. I'm going to add the fire to the paper, and then we're going to observe. We want to make certain we get what we expect. There we go. Soon we have that light. There it is. And I can feel the heat. We'll see the smoke. And soon enough, we'll have our ashes. Okay? This is our chemical change. Light, heat, smoke, and ashes. Pretty simple. Okay? Now, here's the thing. My card burned.
Yeah.
And my paper is burning. So, based on observation, since my card burned and my paper burned, and there are two different kinds of paper, any kind of paper should be able to burn out.
Yeah.
And we should be able to get light, heat, smoke, and ashes. I mean, here, fill it. Alright, guys, what do you think? Can I set that on fire and get light, heat, smoke, and ashes?
Probably.
Yeah, maybe. Okay. Since my card burned, since my paper burned, I think that any paper is going to burn and give me light, heat, smoke, and ashes. Now, this is important because your hypothesis, you're not trying to prove your hypothesis correct. That's not the goal. You just want to test your hypothesis. You do that by experimentation. So, safety goggles on, tongs in hand. There we go. And then, once again, observe, and you will see that we do in fact get light, heat, smoke.
Whoa! Oh, whoa! My eyes! My eyes! That was also magic!
Alright, okay. Now, you got to experiment a couple times because, there could be something wrong with the air on this side of the room, literally. So what we want to do is we want to check out again, and we want to observe, and hopefully we will see that we do in fact get light, heat, smoke.
My eyes! Do my eyes deceive me?
So, first we make an observation, then we have a hypothesis. We experiment and finally we come to a conclusion. That's right. So, after doing some study, after doing some research, after doing my homework, yes, I found out that this is not some cheap tissue paper. This is not wax paper. It's not carpet paper towel. It's not Kleenex, guys. This is not toilet paper. In fact, this is not paper at all. It's a mixture of two very powerful and poisonous chemicals, poured, mixed, pressed, flattened, and dried, and have a chemical compound called nitrocellulose. Yeah, that's a big one. Don't worry about it. Magicians use it all the time in something that they happen to call flash paper. Now remember, as I said, it's not paper. Because everybody knows that paper comes from where?
Trees.
Trees, recycled paper. Trees are made of wood. That wood fiber is what gives us ashes. This, cellulose, leaves behind no ash. And this is important because the magician, they want you to see the fire. And they want you to watch it. Because as you see the fire, as you watch it, 1 minute you're watching it, and it's already there, and the next,
Whoa!
it's nothing at all. There are things that you're just not supposed to mix together that are at home. Here, for example, let's take something that's pretty innocuous, rather safe and harmless. Something like this. Okay. Now, this stuff isn't monstrous, okay? It's not scary.
This is scary. You make faces and they could make...
However, it looks like an alien.
Green bean.
Do you wear it on your head? Yes. Well, as safe and as harmless as this is, it can be really dangerous if mixed with the wrong chemical. It doesn't taste very good. It has bad taste. I have a base chemical that's in some cleaning supplies that you may have at home. This base chemical is extremely corrosive. Okay? You guys remember what corrosive is, right?
No.
Something that would melt your skin off. That's why I'm wearing gloves.
Don't do it on my...
This base chemical right here is so corrosive that if I pour it on my fingers would have a greasy, buttery feeling. Then it would start to burn, and then it would start to bleed. Really gross. Trust me, this chemical is potent, but it is used in cleaning supplies to break down organic material. And guys, you are organic material.
Oh no.
So you're not supposed to touch this with gloves. What happens is if you take this particular chemical, and I'll take it and I'll put it inside of my flask. If I take this chemical and mix it up with my aluminum foil, well, it becomes rather volatile because it generates a gas called hydrogen. Now, hydrogen gas, you don't find it all clamped together anywhere except for in a star. It's the most abundant gas in the universe, but it's volatile. Did I tell you what volatile was yet?
No.
A volatile chemical is something that blows up pretty easily.
Oh.
So you know what we're going to do?
No.
We're going to blow it up. That's right. Yes, it's happy. It's happy for now. So, then, I'm going to use a little pole to tape my balloon onto it. And then, I'll hit it with the torch. And then, we'll see just how volatile this chemical is. So, first things first, let's get our aluminum foil in there. Now, let me tell you, back in the 1930s, people had all these wonderful, crazy, big ideas. And one of those ideas was they wanted to float. They literally wanted to float in the clouds. Hydrogen's lighter than air as well. What's going to happen is, my aluminum foil, it's going to start to react to the hydrogen. It's going to bubble, and it's going to start to bubble up, giving me hydrogen gas. Once I have enough hydrogen gas, it's going to fill the balloon. This is an experiment I've done like over 500 times. So instead of having me blow it up, how about one of you guys blow it up?
I don't know if I can do that.
Who's not afraid of blowing their eyebrows off?
I gotta check my permission.
You sure?
I love that.
Nothing afraid of it, right? All right, blow it up.
My name's Ethan. It does. I'm sure everyone
Hey man, what's up? What's your name? Ethan? All right, face around. Everybody do me a favor. Everybody say, bye-bye, Ethan!
Bye-bye, Ethan.
Excellent. All right. No, you'll stay right here. But you will need safety goggles. And you'll be holding this pole. Here's what's going to happen. We're going to let this expand. We're going to let that build up, build up, build up, build up. Once it's got a nice size in this balloon, what's going to happen is we're going to tape the balloon to the end of that stick. And then you'll hold that stick right over this torch. Make sure we got our torch going. Oh yeah. Good, good. And at that point in time, we'll notice just how volatile it is. There we go. We're warming up. Now, literally what's happening is that aluminum foil is actually dissolving, breaking down into bits and pieces. Okay? And so we want a nice, good-sized balloon there. It's bubbling up. Pretty soon I won't be able to hold this much longer in my bare hand just because it'll be too warm. Like I said, it's an exothermic reaction. It's a reaction that's giving off heat. So as it starts to bubble up, as it starts to expand, as it starts to break down, we're going to have a lot of black, tarry stuff down here at the bottom, our particulate matter. And then we get a nice head right there of hydrogen. And we'll just put that to the test on the torch. No worries, right? Like I said, not a problem.
He's scared.
Now, not all gases are this volatile. Some gases are safe. Everybody take a deep breath in. Breathe out. Well, you breathe out mostly two things. Number one, you breathe out water vapor. And number two, you breathe out CO2, carbon dioxide. Yeah. Now, if I take that carbon dioxide and I squeeze it and freeze it, if I squeeze it and freeze it, I get a little bit of this stuff right here. Yeah, dry ice. Now, dry ice cannot be touched with your bare hands. If you were to eat dry ice, most likely, it would freeze your tongue before you were able to do anything else. And the last thing you want to do is swallow it and let it get down into your esophagus because it'll start to expand like so. This is dangerously cold. I mean, just from here you can feel it. And if you blow across the top, that gas you're seeing, it's water vapor, carbon dioxide. How cold is this? This is 109.3 degrees below zero.
Oh,
Yeah. This chemical is not volatile. This one, on the other hand, is. Ah, yes. Now it seems ready. Seems nice and set. Oh yeah, it's bubbling good. At this point in time, this is definitely too hot for me to touch for any extended period of time. So I'm going to let that bubble for a second. Actually, I'll move it back just a bit so I can take it off and tie it up. No, it's not going to bounce off of here. That's not something I'm worried about. Okay. This is where it gets hot. All right. And now, let's see just how volatile this chemical is. Get ready? This is a controlled explosion. Guys, be ready. All right, hold it right over the torch. Whoa! Give them a big round of applause. When I buy a bunch, it comes in a bag like this. It comes in a big retail bag. If you ever noticed, it's all clear except the big red letters. You know what that means, right?
No. It means for kids that eat. You don't put your stuff.
Hey, I'm not going to read it all. I'm going to read a little bit so you guys can understand what we're talking about. Warning, dry ice caution. Do not touch without gloves. Do not put in drinks, do not eat. Do not touch with skin, mouth, or eyes. Do not put in airtight containers. Do not put in sealed glass containers. Keep away from eyes, nose, mouth, and tongue. Handle only with gloves. And of course, the biggest warning of all, keep out of the reach of children. We will not touch dry ice with our bare hands. As I said, it's 109.3 degrees below zero Fahrenheit. It's negative 79 degrees Celsius. Dry ice is so cold, if you were to touch it with your bare hands, your fingers would start to freeze and stick to the ice in 2 seconds. Literally. Yeah. Well, hey, let me explain what I mean. Dry ice is cold enough to give you something called third-degree frostbite. Third-degree frostbite means your fingertips would be frozen solid. Now, if your fingertips are frozen solid, yes, they'll thaw out. But you won't be able to feel anything with those fingertips again. And then they start turning funny colors. Yeah, they turn green, they turn blue, they turn purple, yes, and eventually they would turn pitch black. Now, if your fingertips are pitch black, that's dangerous because it can poison your bloodstream. But don't worry, it's real easy. You can just go to the hospital, have a nice, simple surgery called amputation.
That's cutting off your finger.
Yes, they take your fingertips and chop them off.
Oh, I want to do that.
Now, listen, guys, I'm telling you so directly. I'm telling you so graphically because I go a lot of places. I mean, by the end of the year, I'll talk to tens of thousands of kids. Everywhere I go, there's always some crazy kid that goes, Nitro Joe, I don't believe you. You're exaggerating. See, the problem at hand is you're too old and slow. If you're fast like me, you can touch it and not get hurt. Don't believe it. Okay? So, let's remember. The dry ice here is 109.3 degrees below zero. Okay? This quarter is about our body temperature, 98.6 degrees above zero. That's over a 200-degree difference. So with that being said, I want you to watch carefully, but also listen closely.
Whoa. It's like fire. That's not moving.
Ice cold? It's freezing. What causes it to move? Well, other than the fact that it's freezing, no. Well, here's what's happening. When I put the quarter down, it generates a small cavity. There's a little space right here. Small amount of space. And all of this gas that's coming off, this is water vapor and carbon dioxide. It's pushing up. It's constantly pushing up on all sides. So think about it like boiling, sizzling a little bit right there. And that's why it's going back and forth, because the gas is coming out of the wrapping case. Now you guys saw that I did put 2 quarters in because the first one froze in about 8-9 seconds. So,
Slower than our hand.
this is a piece of metal. If this piece of metal is going to freeze in about 8 seconds, guys, you're made of flesh and blood. Do you think it'd be a good idea to touch dry ice with your bare hands?
No!
No, don't do it. Couldn't even touch this, because I'll tell you, it would leave a mark on you for a week. It was like a freeze breathing. I've got a glass jar, got the bottom of a 2-liter bottle. It's got about 40 holes drilled all through. What I'm going to do is I'm going to take some dry ice. I have these pellets of dry ice. These are all broken up in their smaller pieces. I'm going to put on the outside between the glass and the plastic, I'm going to add my dry ice. Inside, right there in the middle, that's going to be an open space, because what I'm going to do next is I'm going to use the chemicals that are in this 1 liter, that are in these 2 1-liter bottles. This chemical up here is called denatured alcohol. What I'm going to do with the denatured alcohol is this. Dry ice is minus 109.3. That's a temperature. Well, denatured alcohol doesn't freeze until minus 130. So that being the case, I can use that denatured alcohol to get as cold as the dry ice. And then you guys can get a good example of how cold the dry ice is just by seeing some of the basic things I'm going to use. I'm going to put some basic things inside of here, and you'll see what happens to it. Now, my denatured alcohol goes in. You're going to see sublimation. All that gas going in. Denatured alcohol also has a certain smell. So if you smell something like a marker or a Sharpie, it's the denatured alcohol. And then, once I have enough denatured alcohol in there, and it gets to a nice temperature, that's when I'm going to add certain things. One of those things I'm going to add, and trust me, all of this stuff are things that we know are safe and they're soft. Safe and soft, that's the key. So, woo, bubbly bubbly. All right. First things first, I'm going to use this right here. Lettuce. I'm going to take it right now, and I'm going to place it inside of my food tongs. Once it's inside my food tongs, it goes right inside of there. Now, let's remember, dry ice is 109.3 degrees below zero. That lettuce has been about room temperature. It's been about 65, 70 degrees for about 2 hours. What's going to happen to the lettuce? Well, it's going to get really cold, really fast. How cold? It'll be this cold. Let's get our food tongs. There we go. Ha. Whoa. Okay. Ooh. We don't want to eat this. Nope, definitely don't want to eat this.
Whoa, it's brittle.
Now, let me ask you, should your lettuce shatter into pieces when you hit it? No, not a good idea. Now we're going to take something else that we know is nice and soft.
Chuck it out my face.
Water balloons are nice and soft. And this is smushy. I haven't even filled it up to capacity, so if that being the case, when I drop it, it's not going to pop. Okay? That's not going to happen. Now, actually, this water balloon's nice and cold as well. Now, here's the thing. Imagine if some crazy person said, you know what, I don't think my water balloon's cold enough. I want to put ice inside of my water balloon. That would not be good.
What would happen? It would just
What would happen if you put ice inside of your water balloon?
Let's find out.
Let's find out, shall we? Uh-oh. Whoa.
No.
Whoa.
It turned a different color.
That's not good. That's not good. Last thing you never want to do is to get hit by a water balloon just like this.
It didn't
let's say something else we all know is nice and soft. Something like bananas are all nice and soft. We know this. We like our nice soft bananas, so I'm going to take a piece off. There we go. So, how soft is our banana here? Let's take a look. Well, you know the best part about these old bananas, right? You know what you can do with these? This stuff is great for instant baby food, okay? Yeah. Remember a crunch, instant baby food. So, this is that banana's about, I think the banana's like 2 or 3 days old. Well, what happens to the other piece of the banana that was inside of our super cold liquid?
It's fun to eat.
Wait,
what's the color? Oh, it's on my tail.
Oh my goodness. Bananas shouldn't crack, should they? Yeah, it's all glossy. Well, it's just frozen. I mean, we're talking about, what, 8, 9 seconds frozen?
I don't know.
Guys, dry ice is simply too cold to touch, alright? Do you think you should put your hand inside of this liquid right here? We can use this safely. We see it in movies. We see it on TV. Whenever you see that mad scientist potion, whenever you see that witch's brew, what you're seeing is this process right here. This is called sublimation. Okay? Dry ice does not melt. If I leave this piece of ice sitting here all day, I am not going to get a puddle of water. Okay? It's going to go directly from this solid into a gas. Now I can't touch this, but the gas is totally safe. Like I said, what you're seeing right here is carbon dioxide and water vapor. Yeah, put your hand up. Just pour it right there in your hand. This is the exact same stuff coming out of the person's mouth sitting right next to you right now. Yeah. This is what you breathe out, carbon dioxide and water vapor. That's all this is. Well, you can't see it in here, but when you guys go outside later on today, you'll be able to see everybody's breath, right? This is what you're seeing. This is sublimation. What you breathe out, carbon dioxide and water vapor. And yes, people actually drink this concoction all the time.
I would totally drink that concoction.
Well, I mean, it doesn't look like this when we drink it. We put it in a bottle, we put it in a can, we call it Pepsi, Mountain Dew, Dr. Pepper. It's soda. Guys, look at your soda. The very first ingredient on the ingredient list is carbonated water. And that's what this is. Carbonated water. Here, let me show you. Let's take, I'm going to use a different flask, and then, here. When you drink too much soda, okay? When you drink too much soda, you get all those soda bubbles down in your stomach. Those bubbles don't stay there. They come back up, it comes out your mouth, you make a funny noise called a... Exactly. That's what's happening. So, this, right here, these are all the same bubbles that you find inside of a soda, okay? So, since these are the same bubbles that you find inside of a soda, if I was to go ahead and taste it like this.
Whoa! Tastes like soda. It's the bubbles!
You know what that tastes like?
Bubbles?
It tastes like a Sprite soda burp.
Give me some! Give me some!
You want to try it?
Yeah! Give me
It's crazy. Alright, not a problem. If you want to try it, just go ah. If you don't want to try it, cover your mouth. One of the things you guys know you should never do is you can never shake up a soda because all that pressure builds. That pressure just keeps building. It's a simple matter. Remember, even though this is a gas, it's matter, and matter generates pressure. Something has to give.
Shit on my face.
Now,
There you go.
this carbonation, this sublimation, these are all basic, simple things about dry ice. But if you really want to go crazy with the dry ice,
Eat it.
we want to use this chemical right here. This chemical is not meant to be eaten.
Oh, I have.
Now, here's the thing. This chemical right here has saved millions of kids at least an hour of agonizing pain because this chemical is known as baby shampoo.
Oh, I thought.
Yes.
What?
That's baby shampoo. That's all. Yes, this way, if we get soap in your eyes, it's all right. Now, if I take this shampoo and shake it up, I get a bunch of bubbles. Now, think about it. What's a bubble? A bubble is nothing more than soap stretched around a gas that we call
Air.
Well, can I put something other than air inside of our bubble?
Yes. Yeah, you could.
I mean, I put something other than air inside of this balloon, right?
Yeah, bubbles.
So here's what we're going to do.
Shoes.
We add a little bit. Ah, yes.
I'm getting hot dogs.
Baby shampoo bubbles.
Oh my gosh, can I put some in my hair?
Well, yeah, it is baby shampoo, so yes, you can definitely just go. Instead of having this go everywhere, if we concentrate, we can blow one bubble at a time. So, here's how we do this. In order to blow one bubble at a time, I have to think about blowing bubbles. Okay. Now, we've already said that dry ice is dangerously cold. Can I put it in my mouth safely? No. So what I'm going to do is I'm simply going to add some water into this tube. Once I add water into the tube, then I'll add my dry ice. This way, we'll be able to generate all the gas we need to blow bubbles. All right. Now remember, think about blowing bubbles.
Oh, that's bubbles.
All this gas is going everywhere. When you blow bubbles, okay, when you blow bubbles, do you guys go outside and blow bubbles by going,
Yes, I
no, not going to work very well.
I mean, I've tried.
Instead, how do you blow bubbles? You go like what? That's right. So I want a more narrow passageway, which is why I'll use this nozzle. There we go. Next, when you blow bubbles, do you take your soap, drink it down, and go bloop, bloop, bloop?
You can't.
That's gross. Don't do that. Yeah. Instead, you reach in, you grab your bubble wand. Now you guys know if you get one of those really cheap small bottles of bubbles, the bubble wand has two sides. One side that's smooth, the other side that has ridges. Those ridges are designed to hold the soap because the soap has a very high viscosity. Okay? So thickness of liquid. Yeah. So with that thick viscosity, we can make soap. You guys stay exactly where you are, let me come in. Stay where you are, let me come in. Stay where you are, let me come in. Stay where you are, let me come in. Don't eat it, it's baby shampoo. And as the bubbles sit there, they get smaller and smaller and smaller and smaller as the gas slowly releases through the carpet. Guys, like I said, all of this is nothing more than regular, basic, old-fashioned science. It's nothing new. It's nothing miraculous. I just want to look at it in a different way because dry ice has been around for over 180 years. They just didn't know what to do with it, so they started making moving pictures. What I have, a bucket of fairly warm water. And then I have my bits of dry ice. Carbon dioxide gas is heavier than regular air, so that when I make my fog,
What happens at the bottom?
it's heavier than regular air. Since it's so much heavier than regular air, it goes down to the point where I can literally take it and dump it right on your head. Simply put. So, guys, like I said, all of this is just regular, old-fashioned, basic science. So, hopefully, you guys saw something neat. Hopefully, you guys had fun. And adults, if you want to say something nice, go ahead and find me on Facebook, nitro.joe.science. Write a nice review, say something neat, say something interesting. But if you don't have anything nice to say, don't go there. Okay? Just keep it simple. Alright? Guys, thanks for letting me show up. You guys take care and enjoy the rest of the weekend. See you later. Bye.